Ladies and gentlemen, good afternoon. My name is Liu Xingmin. First of all, I have to say sorry. Mr. Ge is not here. Who has emergency to deal with, and sent me to make the presentation. The title of the presentation is DHR, a clean district heating reactor. Actually, DHR is not the application of district heating reactor, which means deep pool, low temperature heating reactor, which has a Chinese name, Yanlong. So my presentation is divided into 4 parts. So firstly, I would like to talk about the background of heating. So as we know, according to the date of global final energy consumption, the heating, the proportion, the proportion of heating is 50%. Among of them, the within the heat consumption, almost half is space and water heating. So which means almost 25% is for district heating. So at present, most district heating and cooling system energy is provided by fossil fuel. For example, China's reliance on coal mixed heat production, particularly carbon intensive, releasing around 400 kilo CO2 per kilowatt. The carbon intensity is typically 150 to 300 kilo CO2 per kilowatt hour in Europe for massive use of renewable energy source. Under the Paris Agreement, China aims to have CO2 emissions peak before 2030 and achieved carbon neutrality before 2060. China will scale up its intended nationality determined contributions by adopting more vigorous policies and measures. So, which kind of source can be replaced for to reduce the greenhouse gas emission? So the ideal source is nuclear. So as I mentioned before, DHR, which is deep pool low temperature heating reactor. The reactor core is placed in the bottom of atmosphere pressure pool. A proper core outlet temperature that can meet the requirement of a district heating system is achieved by increasing the static pressure of the water layer. This picture is showing the overall layout of a DHR heating station, which thermal power is 400 megawatt heat. The life is more than 60 years. So the outlife of coal, the temperature of outlife of coal is 98 degrees Celsius. The inlet of hot heat network is about 90 degrees Celsius. This figure is shown called configuration. So, which is no soluble boron. Control rod is used for reactivity control. So the fuel assembly is used for PWR fuel assembly. The average burn up is more than it's about 30 gigawatt a day per ton. This is a reactor pole and import components. So from bottom, it is core support and the core, lower barrel, and the inlet pipe, outlet pipe, and some support component. It's very simple, so it's which means it's easy can construct. The diameter of reactor power of 10 meters. The water depth is about 26 meters, with 1,800 cubic meters water. DHR is also with 3 circuits routes through and 2-stage heat exchange. For the pressure, the heating loop is larger than the second loop, and is also larger than the main loop. To ensure radioactivity do not enter the heat pipe. Also, the DCS is used in the DHR. At present, just maybe in the future, the technology of one key stop and less person on duty will be used. So next, I would like to introduce some technical features of DHR. The DHR has 3 main features. First one is inherent safety reactor, safety and safe and environmentally friendly. The second one is plug and play reactor, which means which is simple, convenient, and measure. So, which means can replace the decommissioned fossil plants and so on. The second feature, the third feature is multi-purpose reactor, because it's PO type, which means they can the reactor can be used for some neutron utilization, not only energy utilization. For safety, for the inherent safety, there are 4 points, a main point. 1,800 tons water in the reactor pore. The second one is the reactor will be built in underground. The third one is no overpressure, RB local, injection and controlled failure of safety valve due to DHR is PO type reactor. The last one is large negative reactivity coefficient. As we know, in low temperature, the volume of water will be increased. It will be increased by the temperature, so which can be induced large negative reactivity coefficient. So we also perform some calculation. This picture is shown when DHR is some severe accident be happened. So for example, SBU ADVAS, which means the reactor cannot be shut down. So the reactor could be automatic shutdown, relying on the negative reactivity feedback without any intervention. So another feature is almost zero radioactive release. So an intermediate isolation circuit whose pressure is here, and that the primary loop is set up to ensure the water. The primary loop doesn't enter the heat loop, as I mentioned before. The reactor is equipped with 4 barriers, effective isolating radioactivity, equipped with gaseous and liquid effluence collection and treatment system. Also, the with zero pollutant release, no carbon emission, no emission of nitrogen oxide, sulfur oxide, dust S, and so on. DHR 400 can be reduced the use of about 3.2 million tons of coal, or 160 million cubic meter of natural gas per year, equivalent to 1,300 hectares of forest station. So also DHR is convenient operation and maintenance and decommissioning. So as I mentioned before, maybe in the future will be which will be automatic operation, easy operation, convenient maintenance, because pump and heat exchanger are located outside the pole. Also, green reuse of site due to smaller source term. Decommissioning can be decommissioning immediately. So suitable siting. So DHR is less requirement for site location. So no special requirement for geological condition. So which means bedrock site, soft foundation site can be adoptable. So no outside emergency and small site area. So can be construct road to the cities. No special requirement for water. So coastal river sites inland can be built. So which means suitable to replace the commissioned fossil plants, access to exciting heat network directly. So for the easy connect the heat network, so just replace the heat source, for example, boiler CHP. So DHR is compatible with exciting network. It's used the base load operate full time during heating season. So for the multi-purpose, so DHR can apply the first application is for energy, district heating supply, refrigeration, desalination of seawater, supply hot water. The last three can be used during no heating season. For the nutrient application, can be used for production of radioactivity isotopes, material transmutation, NDT silicon, gem, tobacco, apparel. Also can be used for NAA, NRG, nutrient scattering, NCT, and so on. And production of nuclear pole membranes. So for the the process of project at present, we have already completed the principal verification. So in 2018, just use the swimming pool research reactor in our institute to verify the heat supply. Now the primary design is accomplished. Main equipment determined or developed domestically now being tested. Exploring the regulation and the standard for DHR have made progress in communication with Chinese regulator authorities. For the site, in the north of China, Liaoyuan, in Jilin province, is applying for project approval. So for the international cooperation, so last year, 2019, we have a small meeting with Photon, discussing nuclear district heating technology and regulations. Also, make some report on IEA. So on IEA annual meeting in 2018 on international conference on climate change and the role of nuclear power in 2019. The Chinese nuclear heating technology provide alternative to combat climate change. The DHR design is widely acclaimed by experts from worldwide. So for a simple conclusion, equipment and technology for DHR is mature and has high level of feasibility in engineering. DHR is safe, environment friendly, and economically competitive. DHR is an ideal alternative to coal-fired heating plant and would make an important contribution to worldwide goal on carbon emission reduction and environment protection. So in addition, I would like give some information about the CNC Nordic R&D Center. So CNC Nordic R&D Center on-site office at the Studiosvik Technology Park. So the center preparatory work started in 2019, measured by CNC Technology Quality and Information Department, operated by CIE in China and by Studiosvik internationally. CNC planned to send staff there, but delayed by the raging pandemic situation. The R&D fields, including nuclear fuel and material testing, light bismuth coat reactor, light water reactor severe accident, reactor water chemistry, advanced fuel development. So the first step is establishment of CNC Nordic R&D Center. The phase 2 is ultimately built a Nordic academic logistic in Sweden. So that's all. Thanks for your attention.